Hello, and welcome to the podcast. Today, we're diving into a fascinating and increasingly vital topic: engineered living shorelines. These represent a dynamic approach to managing our coastlines, offering a nature-based solution to erosion and a way to restore crucial ecosystems. Imagine shorelines designed and built using natural materials like plants, sand, and rock, sometimes with structural elements, all working together to stabilize coasts and boost their resilience. The core idea behind living shorelines is to mimic how natural coasts function. We integrate vegetation and other natural elements, sometimes with additions like oyster reefs or rock sills, to create a stable and dynamic coastal edge. This is a big shift from traditional gray infrastructure, like seawalls, which can harm ecosystems. So what are the benefits? They are numerous. Firstly, erosion control. Living shorelines protect our coasts from waves and storm surge, reducing land loss. They often prove more resilient during storms than hard structures. Secondly, they create and restore habitat for a wide range of wildlife, from fish and crabs to birds and oysters, supporting vital coastal ecosystems like salt marshes and seagrass beds. Thirdly, they improve water quality. The plants and oyster reefs in these shorelines act as natural filters, removing pollutants and excess nutrients. Oysters themselves are incredible filter feeders. Fourth, these are living systems that can adapt to changing conditions, including sea level rise, and can often self-repair after storms. Economically, while initial costs vary, living shorelines can be more cost-effective in the long run compared to maintaining hard structures. They also provide significant economic benefits through services like enhanced recreational fishing. And let's not forget carbon sequestration. Coastal habitats like marshes, often part of these projects, are excellent at capturing and storing atmospheric carbon. Innovation in this field is constant. We're seeing more hybrid designs, combining green vegetation with gray structural elements. This helps stabilize shorelines even in higher energy environments. New materials are also being tested, like basalt rock fiber for oyster shell bags, aiming for greater durability. There is also a growing focus on standardizing designs and understanding the full range of ecosystem services these shorelines provide. Real-world examples show their effectiveness. In South Carolina, projects using oyster shell bags have seen significant oyster colonization and marsh growth. Along the Georgia coast, oyster reefs have survived multiple hurricanes while protecting the shore. In Florida, demonstration sites showcase various techniques, from all-natural approaches to enhancing existing seawalls. Of course, there are challenges. Permitting can sometimes be complex, and each design must be tailored to specific site conditions like wave energy and local ecology. Long-term monitoring is also key to learning and improving. Despite these hurdles, the future for engineered living shorelines looks very promising. As coastal communities face increasing threats from climate change and sea level rise, the demand for resilient, nature-based solutions will only grow. Through continued research, innovation, and collaboration, living shorelines offer a powerful way to protect our coasts and restore vital ecosystems for future generations. Thanks for tuning in.